Chemistry is the study of matter, but where did all this matter come from? So in this goal, we are going to recognize the origin and distribution of elements in the universe. So when we look out into the stars, we can see the stars moving away from us. So this means that our universe is expanding. Well, if you rewind the clock, what does that mean? That means that winding backwards, our universe must have had a beginning. And so this has led to the Big Bang Theory. And the Big Bang Theory is how our universe is evolving. So we know that the universe was once more dense and hot because currently, right now, the universe is expanding and cooling, and we can see that and we can measure that. And so we know that if we rewind the clock backwards, then the opposite happened, that our universe was once dense and hot. And this is just a graphic that's showing this expansion of our universe. So some major evidences for the Big Bang, I'll just quickly go through these. So number one, we are reasonably certain the universe had a beginning, and we can measure and see that galaxies seem to be moving apart from each other. And this is called redshift. So we can look at the colors that are sent back to us from these faraway galaxies, and we see that the color spectrum is shifted more towards the red. So that is telling us that that particular galaxy is moving away from the Earth. Three, we have found remnants of the heat believed to be from the Big Bang. Four, the abundance of hydrogen and helium in the universe seems to support this theory. And five, the same elements are found throughout the universe. So the same elements that we find on the Earth are found throughout the universe. So when you look out into stars, stars have what's called fusion occur, where you have lighter elements fused together to form heavier elements. So when you look out into the universe, we see that the majority of the elements out there are hydrogen and helium, our two lightest elements. And fusion is the way that two hydrogen atoms can combine to form helium. And studying the life cycle of stars, there's two paths that a star can take. If it's a medium or small star like our sun, like the Earth's sun, it follows this first pathway. In the sun, fusion occurs and it can form elements up to iron. And eventually, our star will die, it will burn out, it will burn all its fuel, and it will become this white dwarf. If you have a larger star, much bigger than our sun, um, when its fuel burns out, it has this supernova explosion. And in the supernova explosion, the pressure is so great that heavier elements are formed up to uranium. And these supernovas, these are like the planetary nurseries, or where planets are formed. And so this is just reiterating what I just said. So smaller stars can fuse atoms to form iron, up to iron, but the heavier elements that are found on our periodic table up to uranium, those are formed in those supernova explosions. And when you look on the periodic table, you see that there are other elements heavier than uranium. Well, where did those come from? So those are not naturally occurring elements. And you can tell in the periodic table the non-natural elements because they're outlined. So they're not the solid color like you would see uranium, the symbol of uranium. When you look at, for example, plutonium, you would see an outline because plutonium was made in the laboratory. Looking at our sun, we see that our sun is about middle age. So we can see about half of its core hydrogen fuel is used up. And this is nothing to worry about. You will not be alive when our sun runs out of fuel. So how do they make those elements that are heavier than uranium? They make it by colliding atoms. So this is the big Hadron Collider that's found between the border of Switzerland and France, so over in Europe. And this is kind of a picture or graphic representation of smashing two atoms together and seeing what other elements can be discovered. And through this atom smashing on Earth, we're able to synthesize elements up to element 118. And this is just left over from the 1960s, the big space race and the atomic age. And I just think it's really funny. So this is a little chemistry kit, and it's featuring atomic energy. And I just think that is false advertising, but it makes me laugh. So what is our universe made up of? So first of all, it's not static, so it's constantly changing. But we see that our universe is made up of mostly hydrogen and helium. What is our Earth made up of? Well, because our Earth is a planet, it is made up of heavier elements. So we have elements found on solid Earth. We see that it's mostly oxygen and silicon. So that is found in the rock that forms the crust of the Earth. When you look in our atmosphere, we see that most of our atmosphere is nitrogen, and we have about 20% is oxygen, and then we have other gases that our atmosphere is composed of. What is our sun made out of? Because our sun is a star, it is made out of hydrogen and helium. And we do see from the light spectrums that we get from the sun that there are other elements that the sun is forming. And we see that again, because it is a medium-sized star, the heaviest element that it has formed is iron. So the most common elements of the universe are hydrogen and helium. The most common elements on Earth are the heavier elements, so oxygen and silicon, and we do find the elements all the way up to uranium are found here on Earth. Uh, so when you look at science fiction and they talk about this new element that's found in Iron Man's chest, that is science fiction because we have found all the elements all the way through uranium here on Earth, and we've created a few more up to element number 118. And that's where we are. So I'd hate to disappoint you, but no more elements.